All right, so this question right here, 4.47a, what you want to do first of all is you want to recognize that this is a quadratic form. Okay, and if you guys want to move up a little bit closer from the back, you can, if that helps. Okay. All right, so what you need to recognize is that this is a quadratic form, which means that if we let x equal cos theta, then what we would actually have here is 2x squared. Because remember, this squared right here is the same as, this is the same as 2 cos theta, where it's all squared like that, right? So it's like 2x squared, okay, minus 3x plus 1 equals 0. So that looks a little bit more familiar. And you know, substituting I think is wise. Even if you don't need to substitute, you don't have to. But this is a bit easier to okay. So then I saw some of you actually did this. So we're going to try and do this into two binomials, which is going to be 2x, right? And x, because it has to equal this when multiplied. And the last terms have to be 1 and 1. So we just have to figure out what the sign is. And of course, we're going to have negative 2x, and negative x will give me negative 3x, right? So any problems with A, the substitution, and B, the factoring there? You guys are good with that? Okay. So once we get to this point, remember, okay, well, first we'll have to resubstitute. 2 cos theta minus 1 times cos theta minus 1 equals 0, okay? So when we get to this, we use the 0. Guys, can you guys just whisper over there? Calcs? Hey, Calcs? Calc 30s? Can you guys just whisper? Just so everybody can hear me? Chase? Thanks. Just whisper a bit, okay? So what you want to do is use a zero product principle, which means that each factor, if this equation is going to be true, this one times this one equals 0. If that's going to happen, then either this one or this factor must be 0. One or both of them needs to be 0. So the solutions to this equation comes when this equals 0 and when this equals 0. So we're going to rearrange this equation to put cos theta all by itself. So I'm going to add 1 to both sides. I'm going to divide by 2. And cos theta over here is going to be equal to 1. It should be noted that in this question, I believe that it's what, 0 theta to 2 pi? Is that right? We're looking for solutions between 0 and 2 pi, I think. Pretty sure. Yeah, okay. So here's where this should be familiar now from chapter 4. This should be familiar. We look on the unit circle to try and identify where which theta or which you know, however many thetas we have. Cos of what gives us 1/2. Okay? So cos is going to be our first coordinate, right? It's cos and then sine. So 1/2, here's 1. We go over 1/2 and we go up to the unit circle. So this is going to be pi over 3, right? Right here. So getting a cos of 1/2, pi over 3, and you can just look at your unit circle. Here's the unit circle right here. 1/2 is right here. Cos of 1/2. What is that cos of? Pi over 3. Okay. Whoa, what? Oh goodness. Where was my question here? I lost my question.
The other one was cos theta.
Oh, here we go. Okay, so pi over 3. Anywhere else where it's positive 1/2? Well, it should actually be down here somewhere. Positive 1/2 should be down here, right? So that's going to be at negative pi over 3, or 1 pi over 3. We've got, so that's 60, that's 2 pi over 3. This is 3 pi over 3, 4 pi over 3, and is that 5 pi over 3? Well, let's check our unit circle. 5 pi over 3, yep. Look at this, positive 1/2. Shut that door for us, please. All right. So 5 pi over 3. Now, between 0 and 2 pi, those are the only two instances where we have a positive 1/2 as the first coordinate as cos. And now finally, over here, where does cos equal 1? Well, at 0 and at 2 pi. So theta here Now, depending on exactly what this is, if this is both or equal to, you would list both 0 and 2 pi. I'm guessing that only one of these are included, but if they're both included, then here are your solutions. So, the solution to this question would be all 4 of these put together. Okay, so pi over 3, 5, uh-oh, uh-oh, this is not working. Ah, crash. Okay, it crashed on me. So all 4 of those would be your solution.
Okay, thank you.
You bet. Yep.